So to secure an AWS networking environment, you have to add a security group. A security group are stateful firewalls that control inbound and outbound traffic to the AWS resources. They act at the level of the instance or the network interface. When you create a security group, by default, it will block all inbound traffic and allow all outbound traffic. You can create a custom security group. It will allow a specific port with a specific protocol from a specific source to come on to access your EC2 instance in the public subnet or even in the private subnet. It's very important to do a chaining of security group similar to what we did in the previous demo. Most likely you will have, for example, a web tier. You need to open that web tier to accept traffic from the internet or from any IP. Only when you go to the application tier, make sure to change the security group of the application tier to accept the traffic only from the web tier. Then in your database tier, make sure that your database tier security group allow only the communication to come from the application tier security group. We call this the chaining of security group. You could also create another security layer in the VPC, which is the network access control list or the ACLs. They act at the subnet level, but the security group, guys, remember that they act at the instance level. You can allow or deny a specific inbound or outbound traffic. However, by default, it will allow all inbound and outbound traffic. Access lists are stateless firewalls that require explicit rules for both inbound and outbound traffic. Now, what we mean by stateless? If you open port 22 inbound, you have also to specify that the reply port at 22 is also outbound allow. When you create a custom network access list, you can associate it with a specific subnet. By default, each custom network access list denies all inbound and outbound traffic until you add and you specify the rule that you want to apply. As a best practice, you should secure your infrastructure with multiple layers of defense. By running your infrastructure in a VPC, you can control which instances are exposed to the internet. You can define both security group and network access list to protect your infrastructure at the infrastructure level. You can also secure your instances with a firewall at the operating system level using security group. When you implement both networking access lists and security groups as a defense in-depth way of controlling traffic, a mistake in the configuration of one of these controls will not expose the host to unwanted traffic. To create a public subnet, you need to refer back to the demo. So in order to tag a subnet to be public, remember that you need to attach an internet gateway to your VPC, you need to add a route to your subnet route table that directs the internet bound traffic to the internet gateway, and you need to make sure that your instances have public IP or elastic IP address, and you want to make sure that your security group and network access list allow the relevant traffic to flow. Now let us look to the guided lab creating a virtual private cloud. In this lab, guys, you will use Amazon VPC manually to create a VPC with public and private subnet with an internet gateway and a route table which can route and direct internet bound traffic to the internet gateway, and a security group for EC2 instances in the public subnet, and then you will launch an application server to test that VPC. So the final product of this lab will look similar to this diagram.